Hello everyone. Today we'll talk about generics. Generics is a very important feature of Swift. It helps you to write more reusable code. For example, say we want to have a function called swap2ints, which swaps the value of two integers. So the function body is like this. And then we have two integers x and y, and swap2ints x and y will swap the value of x and y. This works fine for two integers. But what if later on I want to swap the value of two doubles or two strings? Then I have to create new functions called swap2doubles, swap2strings, etc. That is not very convenient. It would be great if we can have one function that can swap the values of two variables of different types. This is where a generic comes in very handy. Here we are rewriting the function with generics. Swap2 with the generic type of t. T is a generic type to denote the data type of the data being processed. And t can be integer, can be double, can be string, can be any classes. And the function body is exactly the same as previous one. Now we can do swap2 with two integers, and swap2 with two strings, and swap2 with two doubles, etc. So we have one function that can swap the value of two variables of different types. This is how generics makes our code more reusable and more condensed. This t is called type parameter because it is a parameter to specify the type. We can not only create generic functions, but also create generic data types, classes, and structures. Here we have created a generic structure called stack with the data type of t. And the stack has two functions, push and pop. Both of them work on the data type of t. And then we can use this class stack for stack of integers, stack of doubles, stack of strings, etc. So this is a very reusable class. And we can use the stack like this. We create a var s equal to stack with integer as its type parameter, and then we can do s.push 45, s.pop, which will return 45. One thing to note is if you want to extend the functionality of the class stack, you don't need to specify the type parameter anymore. You can just reuse the type parameter that has been defined in the original class. In this example, we have created a generic class that can use any kind of data of t. But sometimes we don't want to use the class for any kind of data. We want to use the class for only a certain type of data. That is when you need a type constraint. This is an example of type constraint. We have a class animal and we have a protocol walkable. And then we create a generic function called foo, which takes two type parameters, t and u. However, you cannot use any data type for t and u because t and u has some constraints. T must be a class of animal or a subclass of animal, and u must be a class that conforms to the protocol of walkable. So if we have a class wolf which conforms to the protocol of walkable, we can call the function foo with an animal and a wolf. So this is how type constraints work. Previously, we have talked about how to create protocols. And sometimes it is helpful to create a protocol without specifying the data type that will be used, which means we're kind of creating a generic protocol. And to do that, we need associate type. And here is an example. We have a protocol called a container, and this protocol has a function called append. But we don't want to limit this container to be holding only one type of data. So we use associate type, and the syntax is type alias item type. This means that this container is using a generic data type which is called item type. So the append function is taking a parameter of the type item type. And then we can create a class such as an int stack, which conforms to the protocol of container. And before we go ahead and implement the function of append, we need to specify what the item type is. And in this case, item type is integer. And the function append will take an item of integer. And we can even create a generic class that conforms to the container protocol. For example, here we have a generic stack with the type parameter of t, and this generic class also conforms to the container protocol. And to conform the protocol, we specify the item type is t. And then we implement the function of append, which takes a parameter of the type t. Note that the type alias can be inferred by the compiler, because the compiler will see that the append function is taking an integer as parameter. So if we remove this line of the type alias, the code still compiles, and the resulted binary is exactly the same. Similarly, if we remove this line, again, the code still compiles. And item type is inferred to be the type of t. So that's all about how generic works. Generic is actually nothing new. We have been using generic for quite a while. For example, when we create an array that contains 3 integers, the data type of A is actually a generic structure of array with type parameter of int. And if we create a dictionary that uses integer as a key and string as value, we are actually creating a generic structure of dictionary with type parameter of integer and string. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.